Okay, so the sine and the cosine ratios, we talked about the tangent ratio last week. So here's the sine and cosine. If you take a look at your calculator, because you'll need your calculator again for this lesson, you should see the SIN button, not sin, that stands for sine, and then the COS button for cosine. And it should be right next to the TAN, the tangent button, okay? So we will need those in just a second. Again, we're talking about right triangles. They're not special. They're not the 30, 60, 90 or the 45, 45, 90. So what we're going to do is we're going to take the information that we know and use it to find out something else we don't know about the triangle. Okay, so the first thing we'll talk about is a sine. And again, it's an acute angle, and it's comparing the lengths of the two different sides that aren't the hypotenuse. Now, if you guys remember to tell which one, how do we tell which one the hypotenuse is?
The one that's away from the
It's
right
always across from the right angle. It's always across from the right angle. Okay, so the sines, they're going to tell you which angle we're using. So in this little box, it says find the sine of angle A. So we're looking at angle A, and it's the side opposite. So we would opposite. Ooh. Come on in, different color. I didn't want that big. Okay, let's start. The side opposite, there we go, over the hypotenuse. Okay, now do you guys remember what the tangent was? The opposite over adjacent. So the sine is the opposite over the hypotenuse. Okay, now the cosine says what? It's the side adjacent over the hypotenuse. Okay, so it's just different ratios of the side lengths. Okay, so we have three options. Now the trick to remembering the formula, and again, I'm not going to make you memorize the formula, but the trick to remembering, and what I see, I know Coach Agnew does this too because I've seen it on the papers. It's TOA. Okay, what that stands for, the S stands for sine, and that is the opposite tangent. Why else? Look at where the variable is.
The variable is on the angle.
It's on the top, right? Okay. When we did this on Friday, our variable was on the was it on the bottom or was it on the top? It was on the top. I'm sorry. Okay. So there's going to be one coming up where the variable's on the bottom and we have to cross multiply and divide. And essentially, we're still cross multiplying and dividing here. But we ask ourselves, well, first of all, we have to find what? We would have to use our calculator to find what? The cosine of 39. So I'm going to do that first. I'm going to type in 39, hit my cosine button, and I'm just going to round to, I'm going to put 0.7771. Now, that equals what over 25? Now, ask yourself, what's being done to the variable? It's being divided by 25. What's the opposite of dividing by 25? Multiplying by 25. So I'm going to take my 0.7771 and I'm going to multiply by 25. When I do that, what do I get?
19.427.
42 what?
75.
Oh, so we'll round it to 19.3. And they may actually even round it to 19. Just say 19. Okay? Now, does that seem like a realistic measurement compared to the hypotenuse? Yeah. Is it bigger than the hypotenuse? No, because if you got a number that was, it would definitely not be correct. Okay? Is it way smaller? No. Did I get a negative number? No. Remember, measurement isn't negative. Now from here we can figure out what the side length of this was too, right? What would we use? The Pythagorean theorem. We can figure out what the perimeter of it was. We can figure out what the area of it was. Now, are we going to do that right now? No, but that's something that you would do in the future, okay? Any questions on that? Okay, last example. So, obviously, again, they're telling us that we're going to use the sine ratio, but you need to know why, okay? Because you may get a problem like this, and again, they're not going to tell you use the tangent or use the sine or use the cosine. You're going to have to figure out what information you have and use the correct ratio. Does that make sense, what I'm saying? Okay, so right now, let's just, before we even read the problem, let's figure out what information we have. We have the angle measured, we have the hypotenuse, and then where is the variable? It's opposite, right? So we need to use the ratio that includes the opposite over the hypotenuse, right? And then obviously we can tell that the sine is the opposite over the hypotenuse. Okay, so for us, we're going to do, it says to estimate, oh, this is a ski jump. It says a ski jump, you guys know what a ski jump is? You've been skiing before? The last time I went skiing, I broke my arm. It was good times. A ski jump is 140 meters long and makes an angle of 25 degrees with the ground. To the nearest meter, estimate the height of the ski jump. Okay? It says to estimate the height of the ski jump, find the length of the side that is opposite of 25. Because you know